Hey Math 7, Mrs. Ratsberg here. I'm going to go ahead and start lesson 2.3. Our first set of, the first thing we have to do is we have to do write a couple of definitions. Now we've been using these words before, but now we are officially going to define them. So the first word we are going to define is the word similar. And when things are similar, that means that figures that have congruent corresponding angles and equivalent ratios of corresponding sides. All right, and so that's not anything new. We've been talking about what does it mean for two figures to be similar since the first day of this unit. But now we have officially defined it. All right, and scale factor is going to be beginning to be introduced today. And to be able to, and what you need to know there is a scale factor is the number used to multiply, whoops, that used looked ugly, so I'm going to try again. Used to multiply the lengths of a figure to stretch or shrink it. And I ran out of room, of course. Okay, so those are the two definitions. Now, granted, again, like I've said, we've kind of already defined them, but now we have officially defined them. So now we're going to head on to page 11. So you're just going to see me scroll. Oh, too far. Okay, so lesson 2.3 is called Designing Under Constraints, Scale Factors and Scales in Similar Shapes. So our focus question today, so what we want to answer by the end of class is how can you use scale factors to find missing side lengths in similar figures or draw similar figures? Alrighty, so what we notice here, if we see rectangle A, it tells us rectangles A, B, C, D, and E, F, G, H are similar. Find the length of side AD. Show your work to justify your answer. So what I'm noticing right off the bat here is that my two rectangles are not in the same orientation. And what I mean by that is one of the rectangles, so rectangle ABCD is on its shorter side, and rectangle EFGH is on its longer side. So what I'm going to do very first thing is I'm going to redraw this this rectangle EFGH so that it's in the same orientation. So bear with me, it's not going to be as pretty. So then I just rotated. So now E is in the upper left-hand corner. EFGH. And then we have EH is 9 centimeters. EF is 3 centimeters. And then we know from that information, we can label a few more things here. I labeled it 3 meters, not 3 centimeters. That was my fault. And then I'm going to do the same thing on my other rectangle, ABCD. So that's the question mark. And A to B is also 3 centimeters because they are rectangles. Okay, so the whole point of this lesson is to use scale factors to identify that missing side length. So what we can do right off the bat, I keep saying that phrase, apparently that's like the phrase of the day for me. We can identify those those corresponding side lengths. So DC would correspond, this is not wide enough, okay. So DC would correspond with Oh dear, I wrote the wrong thing, guys. Why you couldn't have stopped me? So I wrote 3 because I think I saw 3, but this would be 6.75 and then 6.75. So sorry. But this is, I was like, my answers don't make sense. So 3 centimeters is DC, so that means from H to G is my corresponding side length of 6.75. And then I don't know, so then my other corresponding side length, my question mark AD would be the same as E to H. So if we first need to find our scale factor, so that's what we practiced last class, or really last Thursday, we are going to need to first identify that. So what we'll do, we will say, well, 3 times what number equals, and then what's our corresponding side length? It's the orange, it's 6.75. So 3 times what number equals 6.75? And the way that we figure that out is we need to undo that multiplying. So that way, meaning we divide. So we're going to divide both sides by 3. 3 divided by 3 is 1. So I'm left with 1x, or x equals. And 6.75 divided by 3 is 2.25. So that means that 2.25 is our scale factor. So that means this question mark times 2.25 is going to get us to 9. Now, you might be thinking, well, that's weird. Why would I do that math that way? And you could say, well, let's not do it that way. Let's do it a different way. So instead, we could say 6.75 times what number equals 3. And so we would do the same thing, divide both sides by 6.75, divide by 6.75, and we would get x equals, then 3 divided by 6.75, and we get this awful number of 0.4 repeating, which I can tell you right now is 4/9. Okay, so then if you know the scale factor of 4/9, all you have to do is you multiply your 9, your side length that you know, so I'm going to write in red. So your side length that you know, you're going to multiply it by your scale factor, and that's going to give you your new side length. So 9/1 times 4/9 would be 36/9, or 4 centimeters. So that means your missing side length is 4 centimeters. Pretty cool, huh? So it wouldn't have been quite as much work had we have done the scale factor in the correct way. But generally, our brains work left to right. So that's what we did, but just be aware of that. All right? So that's how we're using our scale factors to find our missing side lengths. Okay, so let's look at part B. So part B, we see triangles ABC are similar and DEF are similar. Find the missing length, side lengths, and angle measures. Show your work to justify your answer. So I'm going to do one. I'm going to talk about the angles, and then I want you to try and use that method that we did in example A to find the 2 missing side lengths. All right, but the first thing I'm going to do is talk about angles. So we need to identify our corresponding angles. So A corresponds with angle D. Change my color here. Angle C corresponds with angle F. And green. Angle B would correspond to angle E. Okay, so our A and D clearly match up. It's 56 degrees. So that means if we look, angle C and angle F correspond, and that would be 94 degrees. And so angle E and angle B are both missing. But think about what we know about a triangle. We know angles of a triangle add up to 180 degrees. So what we have to do, we have to just do a quick little math problem. So 56 plus 94, 10, regroup the 150, and then just subtract the 150 from 180. And so that means I probably should have done that in green, so I'm just going to kind of highlight it so you can tell. Woohoo! And that means both angle B and angle E would both be 30 degrees. All right, so now we need to find our missing side lengths. And we do know one specific, changing colors again, one angle relation or side length, corresponding side length relationship, angle 6 centimeters, so A to B, and DE is 7.5 centimeters. So use that fact to find side length DF and side length FE. So go ahead and pause and try and do that now. Okay, so hopefully you got started. If not, you continued on to try and figure this out. So let me change colors. So if we need to know the scale factor, so it looks like we need to go from 3 to the question mark here. So 3 times a number equals our question mark. So that's going to be the same relationship as 6 times what equals 7.5. So 6 times what number equals 7.5. So we're going to divide both sides by 6. 6 divided by 6 is 1. So 11 with x equals, and 7.5 divided by 6 gets me 1.25. So that's our scale factor, 1.25. So that means all we have to do is multiply 3. Let me change colors here. So the first one we're going to do is A to C. So D to F is first. So 3, that's not a good color. I'm sorry, guys. I'm scattered. 3 times 1.25 should be 3.75 centimeters. And then let's go, I don't even know, we're running out of colors here. Let's do like this peachy color. So that, and then so 5 centimeters times our scale factor of 1.25. So 5 times 1.25 equals 6.25. All right, so that's that. Okay, so then this next part, it says draw new shapes and label them with what the directions say. So we're just given rectangle A and triangle B. So I'm actually going to start with triangle B and you're going to do rectangle A all by yourselves. So the first thing we're going to want to do is identify some specific measurements. So I'm going to notice that my length of triangle B is 1, 2, 3, 4, 5, 6, 7 units long. Now, because this is not a perfectly beautiful isosceles triangle, it is scalene from the looks of it. I also need to know how to draw this vertice up here. So I need to know how far away it is from the edges of my triangle. So this is 1, 2, 3, and then that means the other one would be 4, and then the height would be 1, 2, 3, 4. Okay. So number 3 says the scale factor from triangle B to the new triangle is 0.5. So what that means is we have to multiply all of our side lengths by 0.5. So times 0.5 times 0.5 times 0.5. So that means our new width of our triangle base from the looks of it would be 3.5. Our new height would be 2, and our new, I don't even know what that's called, distance from the edge of the triangle, I guess, would be 1.5. So let's go ahead and try and draw this. So I'm going to kind of go to the edge because I have a feeling the rectangles are going to get kind of big here. So I'm going to start like right here. So I need to go 3.5 to the right. 1, 2, 3.5. Okay. Now, I need to have my point be 2 units high, so 1, 2, so it's going to be somewhere in that area. Okay, so now I need, from that line, I need it to be 1.5 points away, so about right there. Then I'm just going to connect my dots. And the nice thing about Notability, I'm totally cheating, if you hold down long enough, they get straight. So that would be number 3. So I could even label like 3.5, 2, and then from here is 1.5. Okay, so now the scale factor of the new triangle is 2 times the size of triangle B. So now I'm going to actually erase my red notes because we're done with those, because I want to write again. So you could be erasing, you could be writing it on the side, whatever you feel like you need to do. And I'm just going to change to pink. So again, so now the scale factor is 2 times the size of triangle B. So that means we have to multiply everything by 2. Okay, so 3 times 2 is 6, 4 times 2 is 8, and 7 times 2 is 14. So again, so go ahead and try and draw that now. Okay, so I'm going to go all the way down, and let's see if I can remember these numbers. So 14 over, oh dear. So I'm just going to like start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I'm so good. I feel really, really impressive right now. Okay, and then I need 8 up. So 1, 2, 3, 4, 5, 6, 7, 8. So I need to be somewhere along this line. I'm just going to kind of dot it so I know. Okay, and then I need to be 6 over from my far left. So 1, 2, 3, 4, 5, 6. So here is my dot. I'm just going to go ahead and erase some of this ugly stuff that I don't want, because I want my triangle to look pretty, guys. Okay, now I'm going to go ahead and connect my dots. That was pretty good. Okay, so that would be number 4. And again, I might label some lengths. So from here is 8, and from here should be 6. All right, so you are going to do rectangle A. So the scale factor from rectangle A to new rectangle is 2. And then be careful on the second one. The scale factor of rectangle A is 4 times the new rectangle. So that means this next one, the second one, has to be really small. So go ahead and pause and do those 2 rectangles. Okay, we're back. So hopefully I'm just going to write some labels on here. Your first rectangle, so your scale factor of 2 should have been an 8 by 16 rectangle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I feel like I miscounted. Oh, it didn't save. That's okay. And then 8 down. 1, 2, 3, 4, 5, 6, 7, 8. Well, that one was straight. I don't know why they got mad at me on the last one. It doesn't have to be perfect. Mine clearly isn't. So that would be 8 and 16. So that's A. Or that's 1. Let's erase that confusion. Okay, and then the last one, this is the harder one. So the scale factor of rectangle A is 4 times the new rectangle. So what that really means is that we have to divide this 4 by 4 and this 8 by 4. So we're undoing that scale factor. So 8 divided by 4 is 2, 4 divided by 4 is 1, so I would have a 2 by 1 rectangle. And that would be number 2. All right, and so then finally our focus question. I hope you know how to do this at this point with all these examples. How can you use scale factors to find missing side lengths in similar figures or draw similar figures? Well, what you do is you multiply the scale factor by the original length to get the new length. All right, let your teacher know if you have any questions, and next you should be doing the daily practice. Have a great day.